Right, so this is problem 11-38, and I'm going to read out the problem. The flywheel in figure P11-38 is decelerating at 3 radians per second square while turning at 12 radians per second clockwise. Determine the tangential acceleration and velocity of point P on the rim. Okay, so let me draw the picture. I should have probably drawn the picture first and then read the question, but that's okay. So the angular velocity is in this direction. Because it is decelerating, the acceleration would be in this direction. Okay, and the distance from center to the rim is 0.4 meters. Okay. And this is, so point, you can think of that as point P. Okay. So let me read the question again. The flywheel is decelerating at, so A alpha is -3 radians per second square. Okay. While turning at 12 radians per second clockwise, while turning at 12 radians per second clockwise, determine the angular, so, and the radius is 0.4 meters. Okay, so we're asked to find out what is the tangential acceleration. So we need to find the tangential acceleration and velocity. We need to find the velocity. Okay, so velocity is, so let's find the AT first. Tangential acceleration is r times alpha. Okay, it is r times alpha. So r is 0.4, alpha is -3, so -1.2 meters per second square. That's the tangential acceleration. And velocity v equals r omega. R is 0.4, omega is 12, so that's 48, so 4.8, that is meters per second. Okay, right, so let's solve another problem, 1140. Okay, let me read the question. Pulleys C and D. So let me draw the diagram first. Okay. That's the center for both. So that is C, this is D. Okay, and then there's a weight hanging out. That's A. Here, this is B. So the radius is given 120 millimeters. Note down the, pay attention to the units. It's not meters, it's millimeters. And this is 180 millimeters. Okay, now I'll read the question. Pulleys C and D in this figure are fastened together. Weights A and B are supported by ropes wound around pulleys as shown. If weight A is accelerating downward at 2 meters per second square, A is accelerating downwards at 2 meters per second square, determine the angular acceleration of pulleys C and D and also the linear acceleration of weight B. Okay, so you have these two pulleys that are fastened together, so if one turns, the other also turns. But then because they're connected together, their angular velocities would have to be the same. That means if one covers 360 degrees, the other also would cover 360 degrees, because they're they're joined together. Okay, but what is different between these two is the linear velocity would be different for these two, because they have different radii. Okay, now let's go about solving it. Let's write down all the information that's given to us. Of course, we know the radii, right? R1 is 120 millimeters. Okay, R2 is 180 millimeters, and then we know the velocity, we know the acceleration, linear acceleration of C. Okay, what are we asked to find? Find the angular acceleration of, we need to find the angular acceleration of pulley C. Okay, and angular acceleration of pulley C is given by, we can say that this is what we're going to find. So let's see, we can say that the acceleration of A. Okay, in the past we've used the subscript to show like either tangential or normal, but here the A represents the body A, right? The acceleration, this acceleration. Now this is the, think of, even though here you see that this is the acceleration of this block A, but think of this as the linear acceleration of this wheel of the pulley C, right? So this would be RC times alpha C. Okay, or maybe in other words, maybe I should write something like this. If this is confusing, let me write it like this, right? This is basically what it is, right? So if a wheel is spinning, this acceleration, the linear acceleration, is what? R times the angular acceleration. Okay, RC is what? 180. Is it 180? Yeah, 180 divided by 1000, because we want it in meters, times alpha C, right? Alpha C, and then AC is given as 2. AC is given as 2. Now when you do the numbers, you get alpha C is equal to 0.18, and 2 divided by 0.18 comes to 11.1 radians per second square. Now remember, what did I say? If two bodies that are spinning, if they're tied together, then the angle they cover in the same amount of time would be the same. They would have same angular velocity, and then they would have same angular acceleration also. So C and D would have the same angular acceleration. That is why alpha D would be the same thing. Okay, what changes is the linear thing, right? The linear velocity or the linear acceleration is what would change. Okay, now the linear acceleration of D is equal to RD times alpha d. Linear acceleration of d, this linear acceleration of d is also the acceleration of, right, is also the acceleration of b, right? Doesn't matter this way is the acceleration of b. If this is going down, then this would go up. Okay, so here I'll also write this is also equal to acceleration of b. Okay, rd is 0.12 because 120 divided by 1000 times alpha d, we just calculated 11.1, so this comes to 1.33 meters per second square going up. Okay, because it is a vector, we have to give the direction. If this is so, if there is, so as you pull this block down, this rope down, then this block would go up, right? So that's why this is the acceleration of d. The point to note here is, the point to recognize here is what they're calling a rope, the velocity of the rope or the block, is actually the linear velocity or linear acceleration of this pulley. Same way, the linear velocity or acceleration of d is the linear velocity or acceleration of this block B. That's the only point to understand here.